is video number 3 or 2 or maybe 1, depending on what sequence you're watching them in. This one's over chemical compounds. Remember, the whole topic for week 1, day 3 is over matter, and we've been discussing elements, mixtures, and this third one here is the compound one. Once again, I have this hyperlink opened up over here on the split screen, so we can read it together and go through it. Remember that atoms are the smallest parts of elements that keep the properties of those elements, and that mixtures are physical combinations of substances that you can physically separate. This particular topic is over chemical compounds. And if you look here, I have highlighted for you the definition of a chemical compound. It's a unique substance that forms when 2 or more elements combine chemically. And with a chemical combination, these atoms form bonds, and a bond is basically they're either sharing electrons between the atoms that are orbiting the nuclei of those atoms, or they are transferring electrons from one atom to another. And when they transfer electrons, because electrons are negatively charged, if an atom gives some of its electrons away, it loses negative charge. It becomes more positive. The atom that gets the extra electrons gets in greater negative charge. You have a positive atom, you have a negative atom, opposite charges attract, and voila, you have an ionic bond, which is another type of chemical combination, which I will go into more details in those later on. That's a lot of information in those few sentences. But basically, when atoms borrow, share, or transfer electrons, and they form new units, these units are called compounds. And the atoms no longer retain their identifying properties that made them a unique element. They then take on different properties based on what the atoms or the other atoms are combined with. So, the example here in the reading, the compound carbon dioxide forms when one atom of carbon combines with 2 atoms of oxygen. In the diagram above, 1 gray to 2 red, and that could be carbon dioxide. Another example of a compound is water. That's when 2 hydrogen atoms combine with 1 oxygen atom. Okay, so there are 2 things, and if you're using the hyperlink, you can watch the video on your own. 2 things that are true of all compounds, and the 2 things that are true are number 2 and 3. So you might want to draw a little arrow from here to 2 and also to 3. A compound always has the same elements in the same proportion. Another word for proportion could be ratio. So you always have like carbon dioxide. Carbon dioxide is 1 carbon to 2 oxygen. Another thing is that a compound always has the same composition throughout. So a compound always has the same composition. H2O, if you have a bottle of H2O, pure H2O, it's the same thing all the way through. Because compounds are made of atoms of different elements sometimes, the atoms no longer have their own identifying properties. They take on different properties based upon what they're combined with. So the properties of compounds are different from the properties of elements that form them. If we talk about carbon dioxide. Carbon in a pure form can be like charcoal, which charcoal has some other substances in it, but it could be diamond, or oxygen here is very flammable. But when you combine them, carbon dioxide, you have a gas that we exhale that our cells put together and excrete. So carbon is different from oxygen, but the carbon dioxide is completely different from carbon or oxygen. So a compound, the properties of the compound are always different than from the properties of the substances that make them up. Another example of this is table salt. You have this right here. Table salt is sodium plus chlorine. Sodium's a soft metal. It's usually stored in oil. It can have some explosive reactivity when it comes in water. So this here is sitting in oil. Chlorine's a poisonous gas. But when they chemically combine, you get a solid with different properties because we eat this stuff. Okay. So the sodium chloride, the salt, is very different from the chlorine and the sodium that make it up. A compound has different properties than the substances that make up the compound. The structure of compounds like the sodium chloride, they form crystals, which are a rigid framework packed together. Or they could also form what we call molecules. And so they form crystals or molecules. And then a crystal is a rigid framework of many ions locked together in a repeating pattern. The ions are electrically charged forms of the atoms. So this right here represents the repeating pattern. The green are kind of all lined up one way. The purple atoms are lined up another way. That's a crystal. It's the atoms align in a certain pattern. And then you can have a molecule. And the molecule is the smallest particle of a compound that still has the compound's properties. And a molecule has to be made of 2 or more atoms bonded together. Okay. So that's number 7. Smallest particle of a compound that still has the properties of the compound is a molecule. Okay. And water is an example of a molecule. Carbon dioxide is an example of a molecule. Okay. So brief overview. Everything's made of matter. Anything that has mass occupies space as matter. When atoms are linked together by chemical bonds, either ionic or covalent bonds, they'll form what's called a chemical compound. It's a substance with its own identifying properties. It cannot be physically separated like a mixture. It has to be chemically separated. And the substances that make up the compound have properties that are different from the new compound that's formed. Okay. All righty. So that's kind of a brief overview of elements, compounds, and mixtures. Thursday, we will have an assessment over characteristics of life, how living things are organized, and some questions over scientific method. I will push a formal assessment over what I'm starting here with elements, compounds, mixtures. And then on Thursday, after you take the test, the assessment, I'm going to have some more information on matter. We'll go over that, and you'll probably have possibly an assessment maybe next Tuesday or so over matter consisting of elements, compounds, mixtures. We're going to add to it organic versus inorganic compounds because biology is the study of living things. So things that are living and have carbon in them, classified as organic compounds, we'll go over that more of that on Thursday. So you need to be focusing tonight, Wednesday night, on getting ready for your test tomorrow, which is over on Thursday, which will be over characteristics of life, how living things are organized, and research method. Okay, guys. And don't forget to do your daily assessment for Wednesday. Have it in by 11:59 Wednesday night. All right. Talk to you soon. Bye.